chasing love.
F at x so this is f at x equals negative x cubed negative 2x squared plus 7x minus 4. Right? So I said first thing first, in plotting the function, we must check the what? The y-intercept, right? Which one is our y-intercept there, Putazo? Our y-intercept is negative 4. So it means that our y-intercept is 0, negative 4. Right? And then what about our x-intercept? How do we solve our x-intercept? We let x equals to 0. Ne?
Yes.
We let y equals to 0, right? So we can let our y equals to 0. Then this would be negative x cubed, negative 2x squared plus 7x minus 4. Mostly when we are solving for this, we divide throughout by what? By negative, right? So if we divide throughout by negative, this becomes x cubed plus 2x squared negative 7x plus 4 equals to 0, right? And then we are going to look for what? For a factor, right? What is our factor there? So can you please just try to substitute plus or minus 1, plus or minus 2, plus or minus 4. Anyone that will give us a factor there? It's 1. So x minus 1 is a what? Is a factor. So we say x minus 1 is a factor. So this, what can you multiply to get this? It is x squared, right? And we say plus dx, right? And then from there we do what? We say what can you multiply with what? With this to get that. So it is minus 4, right? So now we are going to look for the value of b, right? So if we multiply this and this, what do we get? Dx squared. This and this you get what? Negative x squared. This should give us what? 2x squared, right? And we can cancel the x squared, so b minus 1 is equal to 2. So b is equal to what? 3. So if our b is equal to 3, then it means that our x minus 1, our x squared plus 3x minus 4 is equal to 0, right? So it means that now we can factorize the second bracket, right? Which is the quadratic, right? It's equal to 0. So our x, our 4, our 1, our plus, our minus, right? So it means that our x is equal to 1, our x is equal to 1, our x is equal to minus 4. And I say, if you are finding that you are having two values that are x is equal to 1, it means that that is also a what? A turning point, right? So we can write here our y, our x intercept, that will be what? 1, 0, 1, 0, and what? Negative 4 and 0, right? Cool. And then from there you can find the what? The turning point, right? What was the formula saying? Right. So it means that now we are going to try to find the what? The turning point. I said we derive this, right? So deriving this means that this becomes what? Negative 3x squared, right? Negative 4x plus 7, right? And then from then we equate it to 0 because our gradient is 0 at the turning point, right? Yes. So this becomes negative 3x squared minus 4x plus 7 is equal to 0. And this becomes 3x squared plus 4x minus 7 equals to 0. And then we can factorize this. So this is our 3x, our x, our 7, our 1, our minus, our plus, right? So it means that our x is equal to negative 7 over 3, our x is equal to 1, right? And we can take these values and substitute them in the original equation to find the y values of the turning point, right? So what do we get if we substitute this into the original equation? So this is our turning point here becomes 1 and 0 and what? Negative 7 over 3 and what? What is our y value? We substitute this into the original equation. I give it its value. What do we get?
Minus 18,52.
Minus
18,52.
minus
18,52.
18,52, right? And then from then we are going to find the what? The point of inflection, right? And I said the point of inflection we are going to do what? On the point of inflection, what are we going to do?
Second derivative.
Second derivative, right? So this is the second derivative of x, which is negative 6x negative 4, right? Negative 18,52. So it means that now we are going to equate this to what? To 0, right? Negative 6x negative 4 is equal to 0. So this becomes what? 6x is equal to negative 4, right? So if we divide by 6 then, so that our x is equal to what? Negative 2 over 3, right? So again, we're going to take this and substitute in the what? Original equation, right? So what are we going to get? Negative 2 over 3. What are we going to get if we substitute that into the original equation? Negative 9,26, right? And then from then it means that we have found all the things that we need to draw this function, right? So let's plot this function. So plotting this function will become easier now, right? So we just follow everything that we will be having, right? Right? So let's count in 3, 6, 9. Negative 3, negative 6, negative 9, negative 12, negative 15, negative 18, negative 21, negative 24, negative 27, negative 30. And then let's count in 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, right? So let's see, where is our function cutting? Where is it cutting? It's negative 4, right? So this is our y-intercept, right? And then it is turning at what? 1 and 0. So it is turning here. And it is also turning at what? The x-axis is also minus 4 and 0. What about the turning point? So 1 and 0, and that one is what? Negative 2 comma something, right? And negative 18. So somewhere here, right? So what else do we have? That's all, right? Right?
Point of inflection.
And the point of inflection is what?
Negative
2 comma 3 and negative 9. So somewhere here, right? So it means that now we can join this point, right? So it means that our function can be now like so that will be our function. Let me see that. So don't forget that the point of inflection said it is the what? The point at which it does what? Changes the direction. So this is cut. So this becomes our f at x equals to negative x cubed minus 2x squared plus 7x minus 4.
Yeah.